So if you will go to this page, first page of your vocab sheet is what we're going to talk about, and we're going to review mean, median, mode, and range. Okay, these are considered the study of data is called statistics. Statistics, now, some of these you might use in real life, all right? You might use mean. Mean's probably the one you will use the most in real life. Median, maybe, occasionally. I will tell you, last week when we went on our trip, I actually asked that question because we were talking about salaries of the people at the places that we were going, because I was just curious what these folks make. You know, we were in Kentucky, and we went to a number of different companies, and we were talking to them and all this kind of stuff, and we were doing other stuff. But anyway, I was just curious, what do people make to work at these places here in Kentucky? Because a lot of it is hard labor kind of work, not fun stuff, I wouldn't think, but kind of hard labor. But anyway, so Miss Mullins, we went together, and she looked up the mean salaries. Okay, the mean is another word for average. Okay, average. And like I said, probably in 5th grade, you started learning how to do average. You may not have heard it called mean, but it means exactly the same thing. Okay, I don't know. 2 names for things always makes me kind of crazy in math. Seems like it just complicates the issue. But who knows how we calculate an average?
You add them together.
You add them together and do what? Divide by how many numbers you have. That's literally it. Okay, so here's just a sample set of numbers: 5, 3, 6, and 8. And basically all you do is you add those 4 numbers together. 5 plus 3 plus 6 plus 8. And how many numbers did I have? 4. So you divide by 4. And that's the average. Okay, we're not going to even calculate it. We're just going to write it down so you know what to do on that. Now, this one's really important to the lesson today, because think about the word mean. And I already told you the name of the lesson today is mean absolute deviation. We're actually not just going to calculate the mean one time, but we're going to calculate it 2 times in a problem. So, mean is the average. As long as you know how to do the average, you're good on that. You add everything together, you divide by how many there are. So, she told me the average salary of these people. And I said, golly, that seems really high to me, okay? Because it came out like $57,000 for what these people are doing. And I thought, that's a good paying job. But here's the problem with the mean. Okay, sometimes if you get a lot of, so let's pretend we're talking about salaries, right? And we get several people at the top who are making a lot of money. What happens with the mean is it can actually be thrown off because you get these extremes. You get a bunch of people at the top making a lot of money, or you get a few people at the bottom. Remember that the mean is just taking all these numbers and averaging them out. So I was like, I don't know, that sounds too high. For people like on an assembly line. Because literally some of these people were on an assembly line, putting stickers on things, right? No way they're making $57,000 a year. I can guarantee you. So I said, well, how about the median? Can you find the median salary? Well, of course she couldn't, because they're not going to report that, because the median is a more true piece of data to tell you about the middle. Okay, all the word median is the middle. So the way we find the median is when a set of numbers is ordered from least to greatest, the median is the middle number. Now, so think about, if we have a whole bunch of people making like $1 million a year, several, they're skewing the mean because they're making the average look bigger than it really is. But the middle number, you're not skewing anything. You're lining everything up least to greatest, and you're saying what's in the middle. And then you can actually see, what does the data look like? Oh, these are small numbers, but look at these really big numbers up here, and not always are these two things the same. Okay, well, we couldn't find the median. I'm guessing the median was a lot lower than 57,000 because they had a lot of line workers at these places putting stickers on bottles, right? Or making sure the bottles go through, or they're putting caps on things, and they're doing that kind of stuff. Just watching the line. They're probably making minimum wage or $10 an hour, $12 an hour. They're not making $57,000 a year to do that, I guarantee you. But we couldn't find that. I would be real curious to know that data. The way that I remember median, think about where else you've heard that word. Where's a real life example of a median? You ride in a car, right? Down the highway. Do you know what the median is? The median is in the middle. Okay? 75. Highway 75, northbound, southbound. The grass in between is called the median. It's the middle. Okay, it means exactly the same thing, just used in a different way. So that'll help you hopefully remember. If you think about the median when you're driving, it's the middle. And you will know even if you don't know now. So when you start driving, you'll hear that word. So let's put some data here. 3, 5, 8, 10, 11. Now notice that I gave you an odd number of numbers. Bless you. Which one's the middle? 8. Okay, and I've already ordered them least to greatest for you. I did that on purpose to save time. That's the median of that set of data. Okay, it's just whatever one is in the middle. Now, if we were to add those up, let's see, that's 8 plus 8, 16, 26, 37. And if I did 37 divided by 5, the average of that set of numbers is 7.4, the mean, but notice that the median is 8, okay? So they're little different numbers. You're not always going to get the same number when you do mean and median. Now, look at this set of numbers, 3, 5, 7, 8, 10, and 11. What's the middle number?
7, 8.
Okay, because there are two, here's what we do. We're going to box those, and we're going to find the average of those two. So just think about what's halfway in between those. That's actually the median for that one. Okay, so not always is the median one of the numbers that's listed. It's the middle number. So if you end up with 2, you have to average those together. 7 plus 5 is, or 7 plus 8 is 15. You divide 15 by 2, and you get this. Yes, ma'am.
What if it's bigger numbers and there's a lot of space in between the two numbers? And they're all like right next to each other.
Well, you're lining them up least to greatest. So because you're lining up least to greatest, you're going to write them like that. Okay. Now, like I said, I gave them to you already lined up because I didn't want to take time to do that. But just know you do have to put them in order, least to greatest first, and then you count. And the way you do it is you kind of go, okay, let's see, there's one on this side, one on this side, one on this side, one on this side. If you've got a whole bunch, you kind of work your way in to see where the middle number is. Does that make sense on how to find it? Okay, mode, the key word with mode is most. And I'm going to always try to give you some key words. If you notice, median and middle have 6 letters, mode and most have 6 letters. It's the number that happens the most. And that's literally all the mode is. You look at a set of data and you go, ooh, that one happened a whole bunch. That's the mode. Okay. Now, this is important. There can be one mode, there can be more than one mode, or there can be no mode. Okay? So like if I look at this set of data right here, is there a number that happens more than once? No. So that we would say there's no mode. There's not one that happens the most. But if I give you this set, 2, 8, 2, 6, 2, 3, 6, 6. What happens the most? 2 and 6. Okay, so that one has more than one mode. Now, if I didn't have the 6 here, it would be 2. Does that make sense, everybody? So you can have 3 different things for mode. You can have no mode, you can have one mode, or you can have more than one mode. You just are always looking for what's happening the most, and that's basically all that one is. Okay, range is the last one. Should have already learned this one. It is the difference between the biggest and the smallest. So I've got here the smallest and the largest numbers, and basically you just subtract greatest minus smallest. And that's how you find the range. So those should be a review for you. Hopefully you've at least heard those before. You may have kind of forgotten because stuff you don't use, you forget. That's just the way it is. There's no way around that. Your brain can't hold that much information, and so it gets rid of stuff that you don't need anymore. But hopefully, like I said, if you've heard it, hopefully it'll come back to you a little faster. So this paper that I'm handing out will help us now focus in on this new one. And you're definitely never going to have heard of this before. Some person down in the state, probably a person who's not a teacher, probably a person who doesn't really know what we do in 8th grade or doesn't know what 8th graders are like, decided that mean absolute deviation was a good thing to teach in 8th grade, which is crazy. Shouldn't even be taught in high school. Should be taught in a college course specifically for people who are going into this major. Okay, that's my feeling on it. So there's my 2 cents worth. But because we have to learn it, I will teach it to you. So there are 2 different kinds of statistics. The first one is called measures of center. The other one is called measures of variability. And let me tell you what the difference is. I mean, look at the word center. What do you think that means?
The middle.
The middle, okay? So when you've got things that are here, we're talking about middle values. So we're looking at what data is in the middle. So already, what data did we talk about that was kind of in the middle of a data? The median and, well, the mode is here, but the mean. Okay, they're really about the center of the data. And it also tells you about the shape of your data. If you enter data into the calculator and you graph it, or you hand graph it on a graph, and we're going to be doing some of that, data makes a shape. Okay, it can look like a straight line, not on a straight line, but it can kind of look like a straight line. We call that linear. It can look like a curve, and you'll learn about that when you go to algebra. We're learning about that right now in my algebra classes. They're called quadratics. They look like a curve on the graph. Okay, you can have all different kinds of data, but usually they're going to be in some kind of a pattern, like a line or a curve. And so we're looking for that. Measures of variability, when things are variable, they're different. They change, okay? So this is how different the data is. So it's sort of like the first set is how are they alike, and the second set is how are they different. Right, and so we kind of put these in these categories. Now, I'm just going to give you the quickest words right here to put in these topics. This is the average. Remember, we talked about the mean is the average, and to find it, you add and divide. And that's the quick and dirty. I gave you the long ones on the vocab. Now, these are the short ones. The median is the middle. And they have to be ordered from least to greatest. And that's very important. You can't find the median if they're not in order. So you always have to do that first. What is the mode? Mode, most. That's your key word there. Okay, mode, most. Now, the range is the difference. Difference means we're doing what?
Greatest to least.
Subtracting. Greatest minus the least. Okay, so you take your biggest number, you subtract your smallest number, that's the range. That's how variable your data is. Okay, so like I said, go back to the salaries. If I have a salary that's $25,000 and I have a salary that's $1.5 million, which is what we would have seen, there's a huge range, right? But I guarantee if you go to McDonald's, do you think their salary range is that great? No. Okay, you got minimum wage, and then you probably have a manager who's probably making like $35,000 a year. Not that much difference there. So your range depends on the group of data that you're looking at. Now, mean absolute deviation. We're going to write down there's 3 steps. The first step is to find the mean of your data. What did we say the mean was? Okay, the average. So we're just taking all of our numbers, we're going to add them up and divide by how many there are. That's step 1. Step 2, we'll talk about as we get to it, you're going to find a difference. And like I said, I'll explain it when we start actually looking at some data. But then the step 3 is to do the mean of the differences. So we actually have to find the average 2 times in every problem that we work. Okay? And the way I remember it is I go mean, difference, mean. Mean, difference, mean. And if you'll kind of get those 3 steps in your head, that's going to help you with this. Now what I did when I created this notes page is I wrote the first one out in great detail. Okay, after that I kind of skinnied it down, and I'll skinny it down each time so that we get some practice with it. But this says, the data represents the height in feet of various buildings. Find the mean absolute deviation for the data set. Okay, so I actually told you, step 1, we're going to calculate the mean. How are we going to do that? Add them together, and then we're going to divide by how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So get your calculators, add them together. Always write down your total. It's real important. Okay? So we're going to write down our total, and we're going to divide by 10. And it says round to the nearest whole number on this one. You're going to want to be careful because it may tell you to round differently. We've practiced that a lot this year, a rounding process. Okay, so people are still adding, so I'll give you just another sec to add those up.
I love how you made yesterday easy, and then today.
I didn't really plan it that way. And that's what you're going to find through this whole unit. Like tomorrow, super easy. This is just the probably of all, it's about half and half in this unit. Several topics are super easy. Yeah, I like scientific notation too. And that's one you'll use in science. I mean, in high school, you'll have to take multiple science classes. You'll take, probably take physics. You'll probably take chemistry. You'll have to take chemistry. And you'll see scientific notation again in those classes. Okay, so what'd you get for your total? 591. And when we divide by 10 and we round to the nearest whole number, what do we get? 50. Okay, to the nearest whole number, we're just going to go with 59. Now, let me just tell you that step 2, super important. Okay, it's creating a data table. And on this one, I created it separately. On the next one, I'm going to show you how to create a data table that's even faster and easier. So what we're going to do is we're going to take these numbers and we're going to move them right down here. So just straight across, let's just copy those numbers down into our data table. Because we don't need them in order on this assignment. We're not doing the median, so because we're not doing the median, we don't have to have them in. Okay, so if you go back to this, remember that I told you your 3 steps are mean, difference, mean. We did the mean. Now what we're going to do is we're going to find the distance each of these is from this number. It's not hard. How far is 60 away from 59? 1. Now notice I'm not going to worry about any negatives here. So I don't care if they're higher or lower. I just want to figure out how far they are away. How far is 58 from 59? How far is 54 from 59? Okay, now if you do it in your calculator and you do 54 minus 59, you're going to get -5. We only write positive values here because can you have a negative distance? No. Okay. How far is 56 from 59?
38.
How far is 63 from 59? 65 from 59? 62? 59? 0. Okay. 56? 58. So that's step 2. You're just subtracting. So you get your mean, and then you take every one of these numbers, and you figure out how far apart they are. So sometimes you're going to have to use your calculator because you're going to have decimal values. These are real easy. Now, the last thing you do is you're going to actually add these numbers, and you're going to divide by what? 10. That's the answer. Okay, that'll be the answer to the problem. So add them all up, write down your number, and then we're going to divide by 10 again. Now this time we're going to keep our decimal. This one comes out to a decimal value, and we're going to keep that.
Wait, so that's it?
Yeah. I told you, it's not hard. It's calculator, but you have to remember your 3 steps. Mean, distance, mean. And if you've got those, or mean, difference, mean, you got it. It's not a hard one because it really, because you have a calculator, that saves you on this. What's your total?
Oh, 27.
Okay, so when we divide, 2.7 is the mean absolute deviation. That's it. Okay, so let's do another one. Now, this time, I left off a bunch of steps. Okay, so we're going to do it one by one. So what's step 1?
Add all your numbers.
Add them together and divide by how many we have. Okay, so this time we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. This one also says round to the nearest whole number. Now, I will tell you, probably the hardest part of this is making sure your data is entered correctly in the calculator.
Wait, if it's, are we rounding or?
On this one it says, round to nearest whole number. Okay, so your total should have been 449. When you round, what's going to be your nearest whole number? 50. Now I'm going to show you a little cool trick. Okay, notice step 2 says create a table. Watch what I do. I'm going to drop a table right on top of this so that I don't have to recopy those numbers again. So I'm just going to make it kind of look like this. Because you do still have to write this stuff down. If you don't write down your differences, you're going to have a really hard time with step 3. But that's a shortcut for creating your table. Not always on the paper does it leave room for you to do that. So sometimes you do have to do it to the side. But boy, if I can, I'm going to do that. All right. So go ahead and calculate your differences. So basically you're just looking at each one of these compared to 50. How far apart are they? And write down your numbers. And then your last step is to just add up those 9 numbers that you just put in and go ahead and keep the decimal value on this. We'll typically always keep a decimal when we do mean absolute deviation. Okay, so what's your total when you add those numbers? 35 is what I got also. And you're going to divide that by 9. And then what's your answer? 3.9. And that's it. So see, now because I've taken some of that work off and created the table on there, you don't have to show a lot of work on these problems. This is the amount of work I want you to show. So you show me what you're adding up to. And here's why, you guys. When I'm coming around and watching you working, if you don't have this number written down right here, then I can't tell if that's where you made your mistake, okay? Because a lot of people make their mistake right here. They just don't enter this data in the calculator correctly. So then you end up missing that. And can you see how then that multiplies? Because if you miss this number, then you're going to miss every one of these and you're going to miss this. So always just write that down, and that way when I'm walking around I can check your work. So let's do this last one. Now notice this one wants us to round to the nearest tenth. Okay, where's your tenths place? First number after the decimal. So let's add them up, get your total. And then when you round, keep it to one place after the decimal on your rounding. What are we dividing by this time?
7.
7. Okay, there's 7 numbers, so we're dividing by 7 for our mean. Okay, so what did you get for your total?
43.5.
Good. And I just want to always repeat that just to double check, to make sure everybody adds correctly. If you're not getting that, then you'll want to go back in and re-enter that. Okay, so what is our mean?
6.2.
6.2. Okay, I'm going to do the same thing. I'm going to drop a table right on top of my data because I created it so it will fit. And this time you may actually have to do a little in your calculator if you're not sure how far apart these are, because you're going to get decimal values when you do your distances this time, your difference. So go ahead and remember, if you do 5.8 minus 6.2, just ignore the negative. We're doing distances, so there are no negatives for distance.
These are all decimal with every number, right?
They're all going to be, yeah,
Except for one of them.
except
5.
I have decimals on all of them.
What about 7.3? It's like 1.1.
Yeah, so it's still got a decimal in it, but yes. Just greater than 1. And then once you get those in there, see if you can finish it up and find your last mean. And that'll be it. Now, anytime you have decimals, that's where you want to be super careful, especially entering into your calculator. That's when it becomes really easy to make errors. So what did you get for your total when you added up these decimal values?
3.1.
All right, and when you divide by 7, you get,
0.4.
and that's your mean absolute deviation. Okay. So it basically represents the distance from the mean. That's what mean absolute deviation is. And like I said, really, unless you're in a statistics field that needs super exact data, you're never going to use this. Okay, you'll use this. You will find average of things. That's a pretty typical skill, but that, no.
Can
So,
you take this?
I want you to do 1, and I want you to do 3. Now, you guys, just real quick, I'm not making you do 2, but do you know how to read this? This is a line plot. Okay, so how many people scored 23?
2.
So if you were actually having to work this problem, you would list your data out over here, and you'd put 23, 23, 24, 24. Okay, as long as you know how to read that, I'm not going to have you do that one. And then let's do 6 and 4. 4, the reason that I threw 4 in there, if you look at number 4, you guys, because it's kind of important, it has 2 teams. Okay, so everybody look at number 4 real quick. It says, Ron prepared this table showing the points scored in a series of basketball games between 2 teams. So notice there's Team X, only 4 data points, and there's Team Y. Here's how you work this one. You need to find the mean and the MAD of this group, find the mean and the MAD of this group. Like I said, only 4 data points, and then you're going to compare them. And I could totally see a STAR question looking like this. That's why I'm giving you 4, all right? So you can work on those, and I'll bring the tape around for you.